describing the relationship of our project with PCK, I think we describe this as kind of a long-term relationship, one that's been built up over many years, and we definitely have had some frustrations with dealing with some of the issues around PCK. And I think part of the time we're going to discuss some of the dirty laundry issues associated with PCK, because I think these are pertinent to some of the things that you folks have been, I know our group was talking about some today too, and I think this will be helpful for us as we move forward. So when we're looking at this, I think to this point, we would just be describing that we're looking at PCK, but after the discussion this morning, I think I would modify and say really what we were looking at is personal PCK, what teachers are doing in action. So the goal of our project was try to understand and describe the development of PCK in action. So what teachers are actually doing in the classroom, and what they're learning in the classroom, to inform the design of teacher education programs and professional development. So we just want to understand what this is. We're not sure that we all bought in, certainly when we started our project, that we even knew what PCK was. We were trying to empirically ground some of the PCK constructs and really understand what this looked like. So we went into the issue of assessing the quality of PCK, so if you ask questions about that, these folks up here could probably answer that much better than I could, because that's something different than what we're looking at. So we were building on the Magnuson model, which I think many of these components are things that people have thrown around some today. So we're trying to look specifically at the knowledge in these different domains, and we also had a piece looking at some of the orientations. Primarily, we didn't deal with some of the subject matter knowledge, just kind of assume that it was intertwined within the knowledge. And our project deals with science, but it also deals with mathematics. So we were dealing with mathematics teachers and science teachers within our study. So what were we trying to do? We're trying to get a snapshot of these same individuals over time and follow them over an extended period of time. So initially, people came into our certification program and we gave them a lesson planning task. And this also occurred at the end of the study. We gave them a similar lesson planning task where they were to design a couple days worth of lessons on a particular topic. And in the science side, they were specific to the different domains in science. In mathematics, we didn't have to deal with that issue. We just gave something around algebraic reasoning. It was much easier to deal with. They also did a video task where they watched a video of something going on in a classroom and they reacted to it, which was intended to measure some of the orientation information and gather information about orientations. Then during the year, and this occurred over a number of years, we had these observation cycles. So 2 observation cycles occurred over a span of 2 to 4 years. And the observation cycle included an initial planning interview that we did with them to talk to them some about the knowledge that they were drawing on to design their instruction, observation of their lesson, then we'd have stimulated recall where we'd play back different parts of what occurred in the lesson. So if there was something where a student said something, we may ask them, what did you think about that? What knowledge were you drawing on? If you changed their direction during a class, we would ask them a question about that. So we were trying, again, to get at this knowledge in action. And the participants were these math and science teachers, I said, and then this alternative certification program. And when we did this with the observation cycles, this is for 2 consecutive lessons. So 2 consecutive lessons in the fall, and there are 2 in the spring, and that would be the 2 observation cycles. Again, some people we followed through 4 years doing this. So I'll give you an example of some of the protocol questions. So we're trying to understand their PCK of learners. So we would ask questions like this. How do you expect students to perform on whatever task they were given? What strategies might you expect students to use for this task? What responses might students provide? What, if anything, about this topic do you expect students to have difficulty with? And why do you think that? So we're trying to get at the knowledge that they're drawing on. And we would also ask them some questions about the sources. Where did you get this information? Were you talking to somebody else about this? Or prior experience you have had? Another example, PCK of instructional strategies. So we'd say things like around the representations. I noticed that you chose to use a graph or a table or something like that in this lesson as you were planning this. Tell me why you chose to use that particular representation. How do you think this helps students learn about this topic? Did you consider other different representations? And I think one of the tensions we faced was trying to get a sense of teachers' knowledge and what knowledge they're actually using in the classroom, but they also have some additional knowledge. And we bantered this around within our group considerably. I think we primarily wanted to focus on what the teachers are actually using, but it's not to ignore the fact that teachers probably have knowledge that they're not using in the classroom. So that was a challenge that we faced. Okay, so this is a an issue that we started to deal with. So we talked about some of our dirty laundry issues that popped up along the way. So there's some discussion about this kind of discipline level PCK. And initially, we didn't think about this at all. We were just thinking about PCK in general. But if there's some PCK that occurs, and knowledge that they draw on that's very, it could be true for all mathematics education. I'll give you an example, or science education, from a math ed side. I think there's something you could say about student learning. That students have difficulty learning about mathematical symbolism. It doesn't make any difference what grade level or what topic you're dealing with. Students have a great deal of difficulty developing meaning for those representations. So I think that's discipline level PCK. But then, of course, there's topic level PCK. If I'm dealing with this in an algebra classroom, there are specific misconceptions that students have about notation in algebra. Like some students think that A is 1, B is 2, C is 3, D is 4. And that's what you're always trying to figure out. And this is true. Or there are different misconceptions about students don't understand that A and B could actually be the same number. So there are certain topic level PCK issues that could arise. And I think it's somewhat related to this issue of discipline level PCK. I think in some ways you could be developing discipline level PCK, things that you're drawing conclusions off in general from these different things that you're seeing with very specific things in different topics. Then I'm throwing a new one out, and I know Pat kind of thinks this is controversial, so I'll throw this one. The thing that, because we were dealing with very specific lessons, I've always thrown out this idea of, is it a lesson-specific, lesson-level PCK? Something that's very, because you have to apply to a very specific lesson. And I think often in methods classes, what I see in-service and pre-service teachers do is they'll talk at a very general level. But in practicality, you have to play things out in a very specific lesson when you design a specific task for this specific day. So I don't know if that's helpful or not, but it's something we've been thinking about. Okay, so here's kind of the dark side of PCK. I didn't put a Darth Vader or anything up in this, but so here's an example of a transcript where we're interviewing somebody here, and here's what they're saying. It is, hey, they, the students, have these ideas they come in with. So I want to know what those ideas are before I even give them any information, before we do any activities to get an idea of what they are and what we need to focus more on, or maybe emphasize more as we go through our discussions in our lessons. So the question for us became, is that example PCK? So people say things like this. Unfortunately, it doesn't fit in a very nice box. And the reason why we throw this one out is they don't say anything about science, don't say anything about math. This could be a social studies teacher saying something like this. I mean, you could probably probe them some more about this and see what, I think this is actually a science teacher saying this, so I'm assuming they're referring to science. But the question is this PK? Is this PCK? Well, these are things that we have difficulty with when we're dealing with these issues. Then I'll just give you another example, one that I actually just made up. But students learn best by being shown the rules and practicing solving equations over and over again. So if somebody said this, is this part of their PCK? I would argue it's probably part of their personal PCK. It may not be part of this, whatever this canonical PCK is that some people are referring to. So those are challenges that we face. Another one is this, when we've been working with this, we haven't really dealt with the integration of these ideas. We dealt with them very separately, though when you see these things play out in the classroom, they are all intertwined with one another. So example, an assessment. Somebody has a particular curricular goal, they design a task, now they're drawing on curricular knowledge, then all of a sudden their knowledge of instructional strategies or knowledge of assessment to design this task. They have to elicit student thinking, maybe ask particular questions to get at this. Now they're drawing into knowledge of instructional strategies. They have to draw some inferences, and they get some information about their knowledge of student thinking. Then they have to determine follow-up actions, which again are instructional strategies. So just within this relatively simple process, they're drawing on all kinds of different knowledge bases. And initially we didn't think about it that way. We tried to separate it out and it caused some problems for us. Another one is the issue about what seems to be some overlap between the PCK categories, and one is about, does something fit into an assessment strategy or an instructional strategy? So if I use a formative assessment probe, was that an instructional strategy that they're showing a knowledge of the instructional strategy? Was that knowledge of assessment? We also had situations where a student would, or one of our teachers would say, yeah, I'm using homework in my class today, and here's what they're doing with homework. And people would say, oh, that's assessment. Homework is assessment. They did not see it as assessment at all.
They thought it was just an instructional strategy. The only reason I'm giving homework is so people will learn. I'm not using it to assess anything. And that's really the way they viewed it. So is this knowledge, is this view of PCK, is it from my perspective as to what this should be, or is it from their perspective? And that was one of the issues that we grappled with. So just a general discussion about strengths and limitations to it. So we do have these rich case studies of practice. We have this nice fall of knowledge over a long period of time, and we have this inductive approach that we use to try and ground this. But it's very time-consuming, and we dealt with some of these issues about disconnection of these PCK components, and we really didn't think much about the context issue either, which is one thing I think has been helpful for us to be here, too, to think about that some more. And that's it.